Hey, you. I hope you're having a good day. I've been talking about sea level quite a bit because, the leveling of water is a fantastic way to have a conversation about how things work on the Earth. So I'm doing a little bit of homework here. Sea level is the mean sea level, or mean sea level is an average level of the surface of one or more of the Earth's oceans from which heights such as elevation may be measured. So sea level is the average level of the surface of one or more of the Earth's oceans. That's a little bit ambiguous, isn't it? MSL is a type of vertical datum that they're trying to get it clever here. Vertical datum, a standard geodetic reference system. That's all bollocks to confuse you. That is used, for example, as a chart datum in cartography and marine navigation, or in aviation, as the standard sea level at which atmospheric pressure is measured to calibrate altitude and consequently aircraft flight levels. So if an ocean, let's just say the Pacific Ocean, has an average sea level of X, this is the level, it's the sea level, then would that sea level be the same, say, at the Atlantic, where Ireland met the Atlantic and where America or South America touched the Atlantic? Would that be the same sea level? And therefore would ships and airplanes work out that when buildings and towns work out their height from sea level on that same basis? A common and relatively straightforward mean sea level standard is the midpoint between a mean low and a mean high at a particular location. Now, one accepts that there is a variation in locations of sea level. Some raise higher and some raise lower, but we're talking about inches and feet. We're not talking about meters and kilometers in height, which is what you would expect on a ball. So I thought I'd do a little bit of research here. I've got a Getty Images artist's rendition of what an ocean might look like on the ball Earth. Actually, if you look at the folder that this Getty image comes from, it comes from their cartoons section. So this is, when you went to school, a more likely representation of what you would see. You would get a continental crust like this. You would get a continent, a whole continent sticking out like this. And then the teacher would say, here's your continent, Europe or America or Africa. This is where you live. And then these are the oceans on either side. If this is an entire continent, and I would suspect, therefore, that this distance could be, 1,000 miles, and this distance could therefore be another 1,000 miles and a few thousand miles over this way, why do you think the Merriam-Webster decided that they didn't need to bother with any sort of curvature in here? That's interesting, isn't it? We'll move on. That's probably some kind of error. Oh, look, here's another artist who's done a fantastic rendition of the South American continent over here, which is, as most people know, a fairly large body. Using that as a reference to the size of this drawing, this Pacific Ocean distance here could be thousands of miles. Now we know, if we've done any research on the ball trigonometry, spherical trigonometry, that this curvature here should be significant. If this is 3,000 miles or 2,000 miles, then you're talking about a few hundred miles of curvature. Where is it? Here's one that people might cause you to think a little bit. Yeah, this is the North American subcontinent or subcontinent, and ask yourself this question if you're still a proponent of the ball. If there's an average sea level in this mean average sea level taken, that means that the sea level in this part of the ocean is the same as the sea level in this part of the ocean, because it's a mean sea level. And then one would assume that the same applies here. I know that the Panama Canal does have a lock in it, but that has to do with the way they've run it up to a lake. So I wouldn't really bother too much about that, but I'm fairly sure that the people who live here and the people on this coast down here and the people who live here do not say, well, Yes, there's a huge difference in the ocean heights between here and here. The best research I have suggests that there might be a 9-inch seasonal variation to do with variations in tides and so on. And as far as I can tell, that's because what you've got is you've got undersea pumps pushing in water from one side and pulling it out from the other, and that does cause a slight drop. And in the scheme of the depths of the oceans, 9 inches is minuscule. It could even be a reading error. It's so little. But ask yourself this question then: if you're standing here and the ship is leaving you, when you're going down from California, let's say, and the ship is going over a curve of the Earth, how is that going to be represented as a change in sea level if the mean sea level is considered to be the average level of this entire ocean? And as they sort of mealy-mouthed admit, other oceans could be on that exact same sea level. Hopefully this is food for thought. Sorry for my low-res presentation skills here, but I haven't yet quite figured out how to do the other clever stuff. I just added this as another kind of graphic to remind people that, you know, when most people think about this is your mean high water, so this is your sort of highest level, lowest level, this is your mean sea level here, this line across here. A spring high tide, an annual storm might cause the waters to rise to this level, and a 100-year storm, they claim, would rise to this level. Now, remember, what they're doing here is they're drawing these parallel lines. And this is what most artists would do with a body of water, quite honestly. They would just do parallel lines and say, well, yes, this is the level here, and this is the level there, and so on, because we know the water is just going to go up. And if this was England, for example, and on the other side of this drawing was France, we know that we could carry on this line all the way across to France, and they would endure a high tide or a high level similar to that we were experiencing on this side of the English Channel. So that's my short little presentation on the tides. Bear in mind that if the Thames River, as the tide rises each day, it pushes up the Thames River some 40 miles from the estuary to the Thames Barrier. Now, the tide rises at about, these are slightly rough figures, but the tide rises about 10, 11 meters, up to about 10 or 11 meters at the coast, which is a massive tidal rise. It really is a massive tidal rise. I was brought up in Durban, where the tidal rise is less than a meter, I think, maybe a little bit more, but not much. But the 10 to 12 meters tide rise here can cause problems, which is why upstream, which is why they built the Thames Barrier, massive barrier. Now, the BBC say the barrier stands 15 meters tall. The UK government website says it stands 20.1 meters or 66 feet tall. People who like numerology will be interested in that, but I don't know why the BBC would say 15 meters and the government would say 20. Nonetheless, if it's 40 miles to the coast and the Earth is curving at 8 inches per mile squared, there should be a rise from the coast to the barrier of some 300 meters, so that they can still feel 5 to 7 meters of tidal rise 40 miles up the river. Then that would suggest that the only rise that's occurring is the gentle rising of the land, and that's only risen about 5 meters by the time it gets to the Woolwich barriers. So where is that 300 meters of curvature that you should have on this even marble, this even sphere that they claim that we live on? So yeah, I mean, sea level, I was out in Trafalgar Square yesterday talking to some people on sea level, water level, and how does the Earth curve on in such a paradigm? And I spoke to a young engineer who's freshly out of his indoctrination camp at university, and he was completely unable to kind of see that, to drop the water level like that, you would need to put some form of lock in place. Otherwise, it would simply be flooding from the high point to the low point. But the barrier at the Thames is very much about stopping a 10, 12 meter surge of water from reaching all the way up into Richmond and beyond. And there's a weir up there as well to kind of prevent water from flooding up. So it's like, how can 10 and 12 meters all the way at the coast get 40, 50, 60, 70 miles upriver? But for the fact that it has to be less than that 10 or 12 meters in height, the distance, because otherwise water would not go any higher than the highest point of the water. It would start to fall back to the lower point, which would be surely the ocean. Anyway, I won't belabor. That's long enough. Have a super day. Thank you very much, and goodbye.